I'm going to be talking about the first derivative test. I think the best way to explain how to do the first derivative test is to do a problem. So if you're given the function f of x equals x cubed minus 6x squared plus 15, the first thing you should do is to determine its continuity on the closed interval a to b. Its domain is negative infinity to infinity because it's cubic, so it is continuous on all real numbers. To determine its differentiability on the open interval a to b, I'm going to have to look at the domain of its derivative. So f prime of x equals 3x squared minus 12x. And I just simply use the power rule. And its domain is from negative infinity to infinity because it's a quadratic. And that means that it's differentiable on all real numbers. Being differentiable means that it's continuous, that there are no vertical tangents, and that there are no sharp turns or corners. So in order to do the first derivative test, I'm going to have to set the first derivative equal to 0. I'm trying to find the critical points that will help me solve the rest of the problem. So when I do this, if I take the GCMF out, the greatest common monomial factor, 3x, I'm left with x minus 4. And then I could set each of those equal to 0 and solve for the variable x. So x equals 0 and x equals 4. Those are my critical points. And then I'm going to want to draw a number line and plot 0 and 4. And then I'm going to want to pick points, test points, around my critical points. So I'm going to pick -1, 1, and 5. And I want to determine its signs when I plug these test points back into the first derivative, because being negative means that it's decreasing and being positive means that it's increasing. So if I plug in -1 into the first derivative, I'm going to get a positive value. And that's all I really need to know, the signs. And if I plug in 1, I'm going to get a negative value. And if I plug in 5, I'm going to get a positive value. So then because this is positive, it's going to look like positive slope, and then this is going to be a negative slope. Let me redraw that. So, and then I'm going to use this negative again, so a negative slope and then a positive slope. So that tells me I have a relative maximum at 0 and a relative minimum at 4. So that's basically how you do the first derivative test. And for the second derivative test, all you have to do is do the exact same process, except set the second derivative equal to 0 and plug your point into the second derivative and like find inflection points. And so that's it.